Hello, good evening. Welcome to another fun edition of Writing Some Haskell. I'm going to stop working on Showtime, probably forever, but we'll see. I got a little bit bored of just doing the same thing over and over again. I kind of lost track of both writing a proper project and also exploring Haskell. I kind of landed in the middle where I was doing stuff I didn't fully understand, but didn't really lead anywhere. So the original plan was to look at effectful tonight. I'm not going to do that. I might do it in the future because it's interesting. But for now, I'm going to kind of skip it for a bit because I found an interesting problem the other day in work to do with ID hashing. And I thought I'd look at it again in Haskell because I get to play with things like bit shifting and masking and so on, which I haven't really done, I don't think. So plan for today is to write this thing that converts, it takes UUID 4s and converts them predictably into another format, some alphanumeric string. Don't really worry about why, but I think that doing it will be quite interesting. So I'm going to start with a brand new project. And I'm just going to initialize it. I will create, I don't need a lib in an exe. I think just an exe will be fine. Probably not going to write tests, but I'll leave in place anyway. So I'll cabal init and cabal setup, I think. No, cabal build. Oh, doing Haskell 2010. Okay. I tried to be too modern and up to date. Let's have a look at that. So cabal file. Let's change this to be Haskell 2010 because I'm like 2024. I think that's all I've got. There's no tests in there. Okay. Bring up one of these. Oh. Can I say that? Yep. So cabal builds. Okay, it did build. So let's say cabal run. There we go. Okay, amazing new project. So in main, in fact, let's create a new thing called plan. Okay, so the idea is to take a UUID v4, uppercase that, UUID v4, and convert it into a string of alphanumeric characters. I'm going to start with 15 alphanumeric characters, and then we're going to look at 18 alphanumeric characters. 15 is much easier, 18 is more interesting. This is from a system where it's basically bridging two different worlds. One world identifies things using a UUID, and the other world has got some prescribed format for identifiers, and they are alphanumeric characters. And essentially what we're trying to do is say anything that arrives with a particular UUID will always generate the same alphanumeric identifier the other side. As best we can. There might be some collisions. There shouldn't be, but there might be. It's possible. UUID v4. So UUID is 24 bits. Sorry, 128 bits long. But 4 bits of that are used for the identifier for the version. So there'll be a value 4 in the middle of every UUID v4. And then 2 other bits are used for the version of that version, or the variant of that version. And that's another 2 or 3 bits, but probably 2 bits. So effectively, a UUID v4 is 122 bits of random data. And 15 alphanumeric characters is smaller than that. Let's just run cabal REPL for a second. I'll get Haskell worked out for me. So we have a UUID v4 which is 122 bits long. Oops. Oh, it doesn't know what the type of that is. Okay. It's an integer. It should be anyway. Oh. Okay, doesn't matter. This is the number that's coming out. Right, pretty big number. That's the number of unique variations you get inside there. For alphanumeric characters, there are 62 different characters available. So that's lowercase a to z, uppercase, or a to z, depends where you're watching from, uppercase a to z, and 0 to 9. And I said I'm going to have 15 of these, which is only that much space. So we can then say something like, oops, 2 to the power of 122 minus that. Is that right? No, it's right. I want to divide, actually. So 62 to 15, that's the number of variants we can get in our 15 alphanumeric characters. And 2 to 122 is that. So quite a big difference between the two of them. The 62 characters is much smaller, so you may get collisions of stuff that's appeared in the UUID v4, but it's not. But it's going to land in the same place in the thing we're translating into. However, these are very big numbers. So for the number of messages we're generating, the chance of collisions is actually very small. I tried to work this out previously in work, and it ended up as being approximately 0. I couldn't get any closer than that. I know it's not 0, but I couldn't find out what it is, so it's approximately 0. So we're pretty good here. The plan basically for 15 alphanumeric characters is pretty straightforward. So a UUID v4 is 128 bits, which is was that 16 bytes long, and each byte can contain 256 characters or 256 variations. So it's much bigger than alphanumeric. I think that's right. So what we can do, because you tend to see it written as this, I think. Oh, it's something, I can't remember how big these things are. It's something like that. Where each of these pairs is 1 byte. I think that's how it's normally written out. I might go and look that up actually, because it'd be quite good to get the correct format for a UUID before I go any further. UUID format. So it's, give me an example. What I want. I think. So I was completely wrong on the format. But every x, it says every x represents 4 bits. So every 2 x's represent a byte. In this case, or word 8, more accurately. Let's just turn the spell checker off. Okay. So that's the input format. An output format, like I said, is 15 alphanumeric things. So basically what we can do is we can split this into word 8s, or bytes, but particularly 8-bit bytes. And then we can just take the first 15 of those and we can convert it into a value between 1 and 62. So this will be a value between 0 and 255, and then we just take modulo 62 of that. And that should give us an index into our list of possible alphanumeric characters. That's the first thing I'm going to do. The second thing, if I get time, is I want to go UUID v4 to 18 alphanumeric characters. Because this is a real problem I'm trying to solve. And that's interesting because if you do that by just taking each byte and taking modulo 62 of that, you run out of bytes. There's only 16 available here, and we need 18. However, the space for UUID-v4, so the 122 bits of random data, is still much bigger than the 62 to the 18 for the alphanumeric characters. And we don't, it's very wasteful to take 255 and then take modulo 62 of that. We're kind of throwing away quite a bit of random data in there. So what we really want to do is, if you imagine this being the sort of the, I'm just going to take the tail end of this UUID-v4. What I want to do is split it into 6-byte chunks. Oh, can't count like that. Let's say the one. Let's split into this. And then for each of these, that represents a value between 0 and 63, which is 2 more than we need for alphanumeric, but it's much closer. So I will split into these chunks, and then I will take modulo 62 of that because it's slightly bigger than what I need. But then that should generate that. There's enough of these sets inside our UUID-v4 to generate 18 alphanumeric characters. And then if I have time, I won't have time for this, but if I do have time, I could look at, I can't remember which byte it is, but there's one chunk of 4 words. Is that a nibble? Is that half a byte? I can't remember. Anyway, there's one 4-bit value, which is the value 4. And there's another one that's roughly here, where half of this value is the version. So we could look at skipping those. But I don't think I'll have time. I think enough time we've taken up just initially playing with UUIDs and Word 8s, and then playing with UUIDs and Word 64s and bit shifting. Kind of the plan. Right. So back to Cabal. The first thing I want to do is pull in some extra things. So I want UUID, and I have it handily here. So UUID, which is 1315. So we're going to use this for generating UUIDs, as you might imagine. Oops. And the other thing is, actually that's enough for now. We don't need bits yet, but we will do later. Okay, so I'm also going to just change this a little bit. So we'll say error. And then we go back to main. What I really want to do is say, create a thing called convert, which will take an input value. So it's going to take, actually let's say convert will take a UUID and it's going to convert it into a string. The string will be our alphanumeric value. Okay, I should be able to import that. And then convert, for now, we just say const to do. Okay, and then here what we want to do is say interact. So the type of interact is something that takes string to string and then runs it under IO, basically. We need to write the string to string, so we can say I convert input, and that goes string to string, and we can say convert input s is okay. So now in UUID there's something which does some parsing. So I'm going to generate UUIDs outside of this program and just feed them in on standard in and then parse them as they come in. So I can say from string and it should give me back a maybe UUID. So we can say case, I'm going to call it X because that's what it should be called, of UUID dot from string S. And then we can say if it's just some UUID, then we'll call convert on that. And if it's nothing, then we'll just return a string saying error converting UUID. Can I import that? No. Import data.UUID qualified as UUID. Import qualified as that. What's the problem? Oh, case X of, I've got two ofs. Wow, what am I doing? Case that of, okay. Strange bit of mind disappearance. Now, the other day I learned about simple instruction, a beam of DQ. DQ stands for double quad word. A double quad word would be a 128-bit value, which is exactly what I want. When I had a quick look at this previously, the UUID package returns a pair of word 64s if you want it to, but it doesn't return a single word 128. I don't think there's any support in Haskell. Well, I don't know in Haskell, but there's no support in Data.Bits or in UUID for returning a word 128. So unfortunately, I'm not going to use SIMD, and I'm not going to use double plus good words. We're going to have to, it's a little bit annoying actually, because you have to keep track of which word you're in and then where you are within that word. At least it was like that when I wrote it in Go. It'll be interesting to see what it's like in Haskell this time. Okay, so in theory, I can call this passing a UUID. If it is an invalid UUID, it should say error, and if it's valid, it should say to do. That's what I'm thinking. But does it? Okay, so I can say UUID gen, cool, and I can say I'll build. Okay, and then if I say I'll run and just give it some nonsense, and that's good. But if I say UUID gen, fire this into I'll run. Oh, interesting. So why does that work? We can say error converting UUID, colon, and then we'll show the thing it's converting. Why does that not convert? Weird. From string, hyphens may not be omitted, but that should work. Okay, so if I say cabal REPL, oops, import UUID, import data UUID, and then I should be able to say from string, and then I'll go and find that UUID. And it says just that. Weird. What have I done wrong then? Oh, interact takes everything in the input. Right, okay. So interact is going to get a load of input. And what I really want to do is say run convert input on every line of the input. That'll give me back. It's probably better writing this actually. So we can say, I want to say convert input on every line of the input. Lines input, which give me a list of strings. So let me just bracket that. Okay, and then we want to unlines the result of that. Bit messy, but okay, take the input, split into multiple lines. For each line, run convert input on it, then unlines it. To do. Okay, cool. So we got the UUID. Okay, given the UUID, what we want to do is turn it in this 15 value thing. I want to turn it into a list of bytes or word 8s. And then for each word 8, I want to turn it into a corresponding alphanumeric character and then take the first 15 of those. Okay, so first of all, converting it into a list of word 8s is I can say UUID to words. No, to byte string. Okay, so that gives me back a byte string as a list of word 8s, and then I want to map that. So to byte string gives me a byte string back, and byte string I will probably need to import byte string actually, so that's 0, 10, 10, 0. Let me just add that to Cabal. Oops. There we go. So it's byte string. I want that version of it. Second, okay. Okay, so we now have a byte string, and I think we can say bs.map. Make the map ID over that for a second. Make sure there's P. Oh, what's this problem now? What have I done wrong? Oh. Trying this. So bytes, there's a much more recent byte string. I want 0, 12, 1, not 0, 10, 10. It just happens to randomly linked to 0, 10, 10. Well, not randomly, but that's the version it was probably built against. So 0, 12, 1, I think it was. Okay. So that was P, see if it works this time. There we go. Okay, cool. So BS, we're going to import byte string as bullshit. Okay, that's going to give us back a byte string, and then we want to go from byte string to string. How do we try to convert this? So juice, we don't really unfold it, but is there anything that conveniently gives me back a string without having to fold over it? I have a byte string. And I want to go to a string to string. Okay, could never have guessed that. Ah, no, okay, that's a UTF-8 string. I don't really want to go there. In fact, map is probably not what I want, because the type of map is word 8 to word 8, but I actually want word 8 to character. So we have something which is going to take a function which goes from word 8 to something, and it takes a byte string, and I want it to give me back a list of somethings. And that's not the thing I was looking for. Okay, annoying. Let's look at mapping a character by character. So I can replace ID, and I'll worry about this to string in a second. So to map it to character, I'm going to take a word 8, because I think that's what comes out of the byte string. And I'm going to return a word 8, but I don't really want to. But it's going to make the mapping a slightly easier, I think. So given some x, okay, we're going to look it up in an alphanum. So I'm going to say an alphanum is a string, a list of characters. An alphanum, I hope we can use ranges for this. It's going to be A to Z joined on to A to Z joined on to these should be characters, actually, not literal things. So the character A to Z, and then 0 to 9. Hoping that works. Okay, so here I can say let the index be x modulo. Is that ID modulo or is it mod? It's probably mod. 62, because I know that happens with the length of alphanum. In alphanum bang bang idx. Okay, word 8 is there. Okay, can't map character with word 8. So I might look at the folding in byte string. I think. So foldle will, I can give an empty string. It'll take a word 8. It'll return a new string. And the new string will be the old string plus the new thing. That makes sense. So let's say foldle, this now needs to take a string to word 8 to a string. So then we can say the string goes so far, and we can say something like s, we'll just add to the end of it, which is a bit annoying, although it doesn't really matter actually. We could add to the start of it because it just needs to be predictable. It doesn't need to be in a particular order. This idx needs to be an integer, so it'll be something like from integral. Okay. So foldle will now take map character and an empty string, and then that. So what's its problem here? Foldle. It takes a, for all a function from A to word 8 to A. So in our case, it's a string. We're going string to word 8 to string. We're giving an empty string. It takes a byte string, which is UUID from byte string, and returns a string. That should be good. The error is, hang on, I haven't told it, I haven't quite finished. Why was it from byte string? That's not correct. What was it called? So it was UUID. Oh, close the window. Two-byte string, UUID 2-byte string. Okay, now slight mismatch. So I'm expecting byte string, and I'm actually getting byte string lazy. I don't particularly want lazy, but it shouldn't really matter for this example. Now that's going to go away. So now what we should do is take a list of, we should take a UID, split it into a list of word 8, so bytes. For each byte, we call map, well, we basically fold over a list of bytes, mapping the character, and that's going to take an empty string. It's going to take the current value here, so each word 8, each byte. It's going to run mod 62 in it to get a value which we can use to look up this string. And then we're going to do the lookup and join it onto the, I'm going to prepend it to the string we had so far. And that should give us back a 16 character random-ish string. Random but determinatively generated from the input we give it. Let's come up and nowhere. Okay. So taking this as an example, I'll run, if I paste that in and paste it in again, and we get the same answer coming out each time, which is kind of what we want. This is 16 characters long, I think. I'm not going to count it, but I'm going to assume it's 16 characters long because that's what you get in the input. Okay, and then if we want 15 characters, we can say take 15 of those. Okay, so it's slightly shorter because it was VI before and now it's only V. Okay, it's a little bit annoying because this 4 is non-random and it's going to appear somewhere here, and this 8 is quasi-random. Half of it is not random, I think. And that's going to appear somewhere in here as well. I don't exactly know where. But it's not bad. It's close enough. So given some UUID v4, I can pack it into 16, or in this case, 15 characters. You can't go the other way, right? There's not, we've lost some data here, so we can never reverse this process, but that's okay. If we're going one way, we can say, given someone provided a UUID v4, we will always generate the same 15 character identifier from it. Okay. But that's not good because we want 18. So this whole thing is going to have to change. So we no longer want to call to byte string, and we can't just fold over it anymore. What we want to do is write something which will generate values from that UUID by masking and shifting, basically. So what we're going to do is we're going to take one of the two 64-bit values. We want to use a mask to get the last 6 bits out, and then we're going to convert that. You're going to use map character again, but we can use that to get our value. It's not going to be given a word 8 this time. It's going to be, we can give it a word 8, but the word 8 will only be the last 6 digits. 6 bits. So we'll do that, and then the second time we call it, we want to shift everything to the right by 6 bits and do it again. To do that, I think I want data.bits. So let me just add that to Cabal, and then I'll have a go at using it. So this was bits. And that version. Give it a second. Maybe. It's taking longer to install bits than I thought it would do. I thought that'd be quite simple, but obviously not. Bits has got a type class. I don't know where it is. It's a type class called binary, I think. But no, this is what I want. Maybe it's extras. None of these look like what I want. Maybe this is not the right module. What I want, essentially, is this operator, which is a bitwise and then I want a shift as well. Those are two things I want, which are in base. Actually, I didn't need to install data.bits. Okay, so let's uninstall bits. We don't need that. While that's running, let me just grab fish for a second and say Cabal REPL, and I'm going to play with this. So my thinking is, if I say, let's say A is equal to value 67, and it's an integer, well, let's say it's a word 8. Import data.word. Yeah. So I can say A is equal to 67 and it's a word 8. Okay, and then I say A and I mask it with 64. Hoping this gives me the value 3. No. Import data.bit. It says it's in base. Let's try and point data.bits. Oh, sorry, 67 is quite big. No, it's not very big. That's one to do. 63, because 63 is the top end of the last 6 bits. So basically what I'm going to do is I'm going to take 6 bits. So I'm going to take my value, I'm going to AND it with 63, that'll give me the last 6 bits. And then I will want to convert it, like take modulo 62 on that, and then shift and do it again. The other thing I'm interested in using is unfold. So unfold R, probably. So unfolder builds a list from a seed value. Takes on, returns nothing if it's done producing, or just A and B. So just A and B is going to be, A is going to be my last 6 bits, as a word 8. And B is going to be the initial 2 64-bit values and something to track where we are inside there. I think I haven't done this before either, so this is really interesting. So let me just say what do we want actually? So our, like, I shouldn't call it UUID, I can't call it capital UUID, our source ID. Cover this up. So it's got bits. No, it's not got bits. It's got words, which is a pair of word 64. Ooh, that's all I wanted. Okay, so those are going to be the two things you get back by calling to word 64 here. And the UUID that we're given. It's also going to have a, it's going to have like a word index. I'm just going to say it's an int, but really its eyes are going to be 0 or 1. And we also want a shift index, which is going to be an int as well. So initially that's going to be 0. We're going to say we take the first word, the 0th word, and we shift it by 0 bits, and then we get the value back. And then we increase this shift index by 6. And if we've exceeded the value 64, then we set to 0 and increase this thing, the word index. Okay. So we're going to say to 6-bit values, maybe just call it to chunks, because I know what that means. Okay, and that's going to take a UUID, and it's going to return a list of A's, where A, in this case, is going to be a word 8. So I'm going to go from a UUID to a series of word 8s. Is that safe? I know it's safe, but does the compiler not? So, sorry, what I'm thinking is when I mask a UUID 64, I think I will get another word 64 coming out of it. But I don't, like, I know what size it is. I know it's 6 bits long. There's nothing interesting in the rest of it. It's all going to be zeros. So I want to take the last, I want to convert it into word 8, but I don't know whether or not I can do that in a safe way, or how the compiler is going to feel about that. Find out. So given some UUID, I'm going to say on folder, and that takes the function first, and then it takes this source ID, I need to fill in a second, and it should return a list of whatever function returns. Okay, so I can say let words equal UUID to word 64 of UUID in here, and now I can say the words is words, the words index is 0, and the shift index is 0. Oh, I need to say this, sorry, the words equals that, word index equals that, and shift index is equal to that. What's the problem? Could refer to various things. Okay. Let's not call it anything. And this. And I've got a random y in there. Okay. So on folder not in scope, we can import that from please scroll, data list on folder. Okay. It doesn't like me calling this words. Let me call it word 64s. And then I'll call this word 64s. Word singular 64s. Okay. Where function, right? This is so the type of function now is going to go from a source ID to a, what was it given? Sorry, it's given, no, it's going to go from a string no, it goes from source ID, sorry, I take it back, to maybe a word 8 and a source ID. So the implementation of function, right, given some source. First of all, I'm going to say let w equal, and then this is going to be nasty. So if source dot I want record dot syntax. Oh, it's only one file, so I can do it here. Are they going to give me help for this? It's not. I want record.syntax. That's where I'm going with this. Let's stick in here. Default language extensions. Is it record.syntax? The thing I need. Default language extensions doesn't work. Language extensions. No, default extensions. There we go. Just guess it. The syntax that goes bold. Record.syntax it does not know. So let me just say Haskell record dot overloaded record dot. Oh, it's called overload record dot and duplicate record fields. I don't have duplicates yet. Overloaded record dot. See, that's only half here. Cool. Okay. Oops, don't mean to do that. Okay, so here we can say if source dot word idx is 0, then first of source.words, else second of source.words. Okay, that's horrible. Let's make this a function which goes from that. And then instead of initializing it to 0, we'll initialize it to first. So, and then I'm going to call this getWord. So W can now be source.getWord of source.words. Just going to restart LP, see if it comes back to life. In. Okay, so we have the word we're operating on. So now we want to say the value that we're going to return is word. Then we're going to do our shifting. And then we can say source.shift index. So we're going to, let's just call this shifted word. And then the value is going to be shifted words ANDed with 63. In, and then we've got V, it's going to be tuple, right? It's going to be just V. Oh, this is annoying. Get word is going to say, given a pair of word 64s, return a word 64. Okay, it's going to be just V, which is the value we've picked out, and the new source ID. So we need to find that as well. Hopefully shift we can just import from Data.Bits. It's going to be a word, it's going to be a word 8, except that's not going to work, is it? So we have to mask it with word 64. We need to find out how to go from word 64 to word 8, and new source ID. This thing I was about to write, so the new source ID is the previous source we had. The words will stay the same, but V, so of course V prime, oh, just so much to calculate. So V prime is going to be it's basically going to be V plus 6, right? Except that I'm going to say if V is greater than or equal to, be greater than, but if we get to the point where it is greater than or equal to 63, no, yeah, we've got 64-bit words, sorry, greater than or equal to 59. Equal to 59, then V equals 0, else, what do I mean by V equals 0? I mean it is 0, otherwise we just increment it by 6. If you go over 59, you increment by 6, you've gone off the end of your word, so we just wrap to 0. And then W prime is, no, it was get word, wasn't it? So get word is if V, so I can pull this out and say wrapped is equal to V greater than or equal to 59, and if wrapped 0, and here I can say if wrapped then second else GW prime. Sorry, else GW else source dot get word. Then here I can say get word is equal to GW prime, and this shift index is equal to v prime. Almost getting there. So expect type int, the actual type, which is 4. Shift index is int. That's clearly an int though, because b is an int. B is a word 64. How did that happen? Oh, it's not v. Sorry, it's source dot shift index. Okay, almost there. Just need to go from word 64 to word 8 if I can. So word 64. I'm going to go to word 8. And there should be some kind of truncate maybe. W8. So from anything that can be integral, go to word 8. I guess. But I'll need to import bits for that, because it's not in base. Unsafe coerce, I mean, yeah, maybe, but it doesn't sound cool. No, let's not go there. One thing I could do is just make this a list of word 64s. Make this a list of word 64s. Okay, so now I should be able to call to chunks and that. I need an exit clause, so I'm going to say if we're going to say, how do we know we're second? Oh, this is really annoying. I'm not going to have an exit clause. This is dangerous. So at some point we will. This is at some point we'll start reading off the end of our two 64-bit words. So that's not going to work. We try and take more than 16 bytes worth. So that's something like, oh, it's 107 bits. I don't know what it is. It's going to be something like 17, maybe 18, maybe 19 chunks. Then it's going to go very badly wrong. But we won't take any more than that. So in theory, map character doesn't take a word A anymore. We're going to say for all A where to integral. A doesn't sound right. I think that's the name of the type class. Oh, that's not probably ranking types. Let's just say assume for all A, and to integral is not a type class, but integral is, I think. And then we can say that. Okay, so we don't care if it's a word 8 or word 64. We just care, can we turn it into an integer? If we can, then we can model it with 62. Well, we model with 60 first, and then we call this on it. Okay, so instead of doing that, instead of calling UUID byte string, I think what we can do here is we can say chunks UUID. Oh, and we don't fold over it now. We just call foldable. Use normal fold over that. Take our UUID, we hopefully turn it into 64-bit chunks. This is super dodge actually. This doesn't work. let me just keep track of that. Then we might as well just put the word index back in again. It was a bit nasty, but this doesn't work. Sorry, what I was talking about. This doesn't work because we get to 58 bits, and then we try it again. And so we get to 64th bit, and then we hit this clause, and we say we are wrapped, so we reset it to 0, and then we set it to second. Well, no, that is safe. Sorry, because we never. If it was second, we don't change it back to first. We keep it as second. No, this should be okay. I think. Let's find out. Does it build? It does not build. Try again. It does build. It must be totally fine. It's running forever. That was not good. Okay. Let me have a quick look at to chunks. So UUID, let's import UUID data.UUID.v4, and then you can say UUID is equal to what's the name of the function there? UUID v4 next random. Oh, what's just next random? Okay, so that's our UUID, and then we should be able to say UUID dot was it towards 64? Oh. Towards 64. Towards 64 of the UUID. Import data UUID. Oh, okay. Type of UUID is actually IO. Okay, reset. UUID comes from next random. Okay, and they can say towards 64 UUID. Okay, we got our two words. We import main. Can we see main? I don't know how this happens. This works. Okay, we can. And then we can call to chunks, and we'll just take two of those. Take two of to chunks of towards 64 UUID. No, we just pass in the UUID, and it should call towards 64 for me. Yeah. Okay, can we take 10? Doesn't look right, clearly gone wrong. Take 16. Can we take 19? Okay, so everything is slightly wrong. So we can say the first word is this. And then we should be able to say W1. That won't work because I've imported it. Import data.bits. Okay, so that gives me back a value. I don't know if it's correct or not, but that's fine. So W1 as an int. Okay, and then can we say shift 6? Oh, it goes funny. So in Data.Bits, or maybe not. Let's go back to Google. Nope. So here, given some A, shift X by I bits. What shift all? I think I'm going to shift right actually. Shifter. Shifter. First I went right by a specified number of bits. If we took something like X is equal to 67, and that's an int. If we say shift R of 6, I expect to get 3 back, and that is not the case. Why is it not the case? How do you format a thing? I want like a printf equivalent. I think printf is probably what I want. Okay, so can I say printf 0 16, no, yeah, let's do 16 bits for now. B of X. Where's printf? In text.printf. Good. Okay, that makes sense actually. So if I take it and shift by 6 bits, you're left with that, which is the value 1. So if X was much bigger, and now if I say shift R of 6, it moves. Okay, so shift R seems to do the right thing. Shift goes the wrong way. Okay, so reload that. Wasn't that at all? It was UUID. Okay, so I have a UUID. Oops, not there. Here, and I should be able to call 2 chunks on that UUID. So we're going to take 2 from 2 chunks. That UUID. That looks a bit better. Okay. I mean, it doesn't quite look right. A lot of 63s now. Which is not what I expected. Okay, I'm kind of running out of time here. What I might do is just come back to this next week, I think, and tidy it up, and then maybe look at skipping the version number. There's obviously something wrong in this logic, which is not that surprising really. I'm a little bit confused as to why it didn't give me an answer though, even if it's a wrong answer, because I should be going to chunks, which should give me back a list of word 64s. And then I fold over it, and it should be mapping them, and the mapping should be straightforward. And then taking 18 of those should be really cheap. It should be perfectly possible. There's no reason why it wouldn't work that I can see. But it just hangs. So there's obviously something weird going on there. Okay, cool. So next week I'm going to come back, work out, first of all, why 2 chunks is not working. And then secondly, I'm going to work out why this is hanging forever. So why this? Oh, because it never turns nothing. This is probably not lazy enough. Should be lazy because I'm taking 2. I don't know why this wouldn't be lazy. But it never terminates. So here I do want to terminate when I'm on the second word and I've run out of bits. We should return nothing, but I shouldn't be. I don't think I should be hitting that, but maybe we're just sitting forever. Yes, I don't know. I'll look at it next week, but I think it's something to do with, I suspect it's something to do with the unfold, not terminating properly. Okay, cool. That's the plan for next week. Yeah, so thanks for watching along. And then next week we'll do a little bit more shifting and masking and hopefully finish the unfolding properly. Cool. Thanks for watching. See you next time. Goodbye.